This video is meant to describe the pH properties of salts, which is sort of the end of our chapter on acids and bases before we start talking about more acid-base reactions. So remember that a salt is composed of a cation and an anion, and it's important that you remember that because you have to consider them separately whether or not they have an influence on the pH of the solution. So our cation is derived from a base. It is either derived from a strong base or a weak base. Strong bases, like the metal hydroxides, will produce neutral cations. And so the group 1 and the group 2 ions, sodium, potassium, magnesium, those are all considered neutral because they come from strong bases. Strong bases produce neutral cations. Weak bases, like ammonia, other amines on the Kb table, will produce acidic cations like ammonium. The anion is derived from an acid. It is the conjugate base of an acid. Strong acids like hydrochloric acid and nitric acid have neutral conjugate bases, chloride and nitrate. They have no tendency to want to reform their acid because the acid is strong. It's unstable. Weak acids, however, like hydrofluoric acid, nitrous acid, acetic acid, they tend to want to stick together. They like being in their acid form, and so their conjugate bases have a tendency to take protons from water to reform the weak acid because the weak acid is sort of stable as it is. So the weaker an acid is, the stronger its conjugate base is. So weak acids, very weak acids, have very strong conjugate bases because remember, if an acid is weak, it's sort of very stable as it is. It likes its hydrogen ion, which means its base is going to seek out hydrogen ion. It's going to want to take a hydrogen ion from water, which is what makes it a strong base, right? So weak acids have basic conjugate bases, like fluoride, nitrite, and acetate would all be bases in solution.